Hello everyone, it's Bill here. Just a quick project this morning. I thought I would film it and throw it on YouTube. The question comes up, how do you put a new clutch liner in? There's a lot of different ways to do it. This just happens to be mine. This is a Align 700XN clutch. For those that don't know, Align went to a steel liner clutch, which I'm not here to debate whether that works or not. I personally fly a lot of low head speed with my 700XN, 1400 head speed, and as well as 2000. But today's project is I'm going to put a heavy steel Lynx gas clutch in it. Please focus. Okay, don't focus. And we have to get a new tolerance and a new liner in there. I'm going to use, this happens to be a TSA liner. So I've already removed the steel liner, and we're just ready to glue the Garlock replacement liner in it. And then we'll just chunk it up and true it. I'm going to use my TAG micro lathe to do most of this. There's, like I say, a lot of different ways to do this. This happens to work for me. Part of the goal of this is to end up with a particularly true clutch. This is a very heavy piece of spinning metal at 16,000 RPM, so it'd be nice if this was reasonably concentric. For today's purpose, this liner is just about right. I've only slightly removed the old XL liner and the glue that was holding it. There should be 9/1000ths, 10/1000ths clearance like this. It would be nice if there was a small interference fit when I get done gluing this. We're shooting for 8/1000ths clearance either side. So I think with epoxy on it, and by the time it's glued in there, we'll have enough material to machine off and get the clearance that we want. That's what we're trying to do here. So let's get it glued up. Alright, we're going to glue the liner in. There's really a little more to this than mixing up some epoxy and putting it in there. A few things that help is we know that this can get messy, so have some cleaning supplies around. Paper towel, swab, and this is really good at removing epoxy. A lot of people will say you can't use JB Quick. I've always had very good luck with it. I've been doing this for a long time. The secret, of course, you only have about 5 minutes working time, which I think some people don't mix long enough. It goes relatively quickly. Obviously, check that your liner has enough end gap. Again, this is an Align clutch and a TSA liner. As it turns out, this is going to work out reasonably well. Shorter is better than longer. We can work with shorter. It'll just leave a little gap if you've cut it too short. I haven't had to trim this one, and I think it's going to snap right into place when we get all around to it. Equal parts A and B. Mix too much. If you don't mix enough, you're in trouble. If you mix too much, you're just wasteful. We're just going to have a thin sliver on there. We'd actually like to build up this machine. When I removed the steel liner, it removed enough material that it'd be nice if we actually could add 5/1000ths. So 5 minutes working time. Really, we kind of want to spend 2.5 of it mixing. I'm exaggerating, but we really got to make an effort to get this mixed properly. Any white streaks or black streaks are going to be a problem. Working time is even less. Again, it's August in Mississippi, so it will not take long for this to set up. It's reasonably thin today. The part against the cardboard, the epoxy against the cardboard, is difficult to completely mix. So that's that. Obviously not 2 minutes. We'll call it 60 seconds, but I think we're reasonably close there. Everything's already been degreased. This is an artist's palette knife. Don't really care if we get it on the inside, because again we're going to machine that. So the goal here is a semi-big sloppy mess. Not terribly sloppy, but thoroughly covered. We don't want it coming out. There are threads right here. There's a bearing right there. Really never an issue. And then it's just a matter of coiling it up. And snapping it in place. And this is where the paper towel comes in. Just going to get the big saucy stuff off. The clock's already running. We want to get some clamps on there. This liner fits tight enough that really don't have to clamp it. We want our toy to look pretty here, so I'm going to make an effort to remove the epoxy that we might see after it's assembled. Convince ourselves that it's properly seated. And then with whatever time is left on our cure time, we're going to pop some little tiny clamps in it. I think you can buy these at Lowe's. I forgot where I got them. We're just going to spend the rest of the time, cure time, trying to clean up the rest of the epoxy. We'll let that set. It's going to dry quickly today, so I don't think it'll be 10-15 minutes, and we'll be able to take some measurements and true that liner and install this clutch. Alright, a minute or two has passed. 10, 15. Our epoxy's set. At this point it looks a little bit of a mess. Quick measurement says that we have maybe 3 thousandths clearance, which is really kind of less than ideal. We're going to shoot for 8 thousandths a side, or 16 thousandths total, so we only really have about 12 thousandths to remove. This material doesn't machine particularly well. It's kind of like machining cardboard. It sort of tears. So we're going to use the TAG microlathe. Hardly a serious industrial tool, but it will do what we want. These are soft jaws on this. It's a 3-jaw self-centering chuck, but they're soft jaws that I have machined for this purpose, and I know they run particularly true. So our goal now is to just trim that for 8 thousandths a side. Some people will tell you it has to be 6 thousandths or 10 thousandths. My number is 8. So we'll set our travel stop here. So we don't machine through the aluminum. Sorry if my head gets in the way. First pass is going to be a fair bit of epoxy that we've so we'll make a pass like that. Hopefully everything is concentric, so we don't have to remove much material to make it round. This not being a full-size lathe, we have the luxury of just removing the chuck without having to unchuck our workpiece. So we're looking at 10 thousandths total here. This has been zeroed, my calipers have been zeroed to this clutch, so so we have about 10 thousandths total, or 5 thousandths a side. So we're pretty close here. We really only need to remove about 3 thousandths. 16 is the total number, and we got 10. We're going to remove 3 thousandths a side. It's nice that it went in relatively true. We don't have any holidays. It's not an interrupted cut at this point. And right now we're looking at about 14 thou. So we could actually take off total of 2 maybe. 16-ish. It depends on how deep I go and the accuracy. So we're looking at right at 16 now, and I think we'll call that good. Depends on where I measure, but we're looking at 8 thousandths a side. Pretty happy with that. I'm going to touch this with some sandpaper. There's a little goo left from our epoxy job. Let me see if I can find some 220 grit. Let's see if that'll focus. So, new clutch. We'll clean it up a little bit. Still a little epoxy in some of the vent holes. Tolerance turned out reasonably good. I'm fairly happy with this. I'm sorry, we're off frame here. Let me zoom out a little bit. So we're measuring about 16 thousandths total. That'll work out to about 8 a side, which was the target. Like I say, this will probably drag just a bit when new and installed. We'll put some magnets in it, put it in the helicopter, and that's that. Thanks.